This is part 2 of section 1.5. We're going to be looking at today is limits at infinity and how to find horizontal asymptotes. Example number 7, which is the first example in this lesson, is just finding the limit as x approaches positive infinity of the function 1 over x. Now you can think of this as you're letting x get bigger and bigger and bigger. That's what x approaching infinity means. So if I have bigger and bigger x values, I'm going to have, well, if I have, like, let's say 1 over 100, 1 over 1,000, 1 over 10,000, that's going to be a smaller and smaller fraction. So as the denominator gets bigger, the fraction itself gets smaller. So this is going to have a limit equal to 0. You could also look at the graph and think of 1 over x. If you remember from your summer packet, the graph of 1 over x looks like this and like that. And as I go towards positive infinity, this eventually gets closer and closer to 0, and we say that limit is going to equal 0. And it's the basic idea of letting the denominator get bigger and bigger and bigger, that it makes the fraction smaller and smaller, which is kind of summarized by this golden rule that I kind of came up with, or what I call my golden rule for limits at infinity. It's that if you have any constant, so c is any constant, and then you have any power of x in the denominator, you're going to have a limit x going to infinity equal to 0. It doesn't matter if you have a positive or negative constant. If this denominator is getting bigger and bigger, the fraction itself must be getting smaller and smaller. Therefore, the limit is equal to 0. Alright? I'll give you guys a moment to pause it and copy this down into your notes. Alright, next example. Let's say if I have this. I have the limit of x going to infinity, and I have this rational expression. Well, this looks nothing like example number 7. However, I'm going to use something to kind of maybe transform it into a similar looking problem. I notice that the biggest degree in the denominator is x to the second. So I'm going to divide every single term by x to the second. This kind of controls the behavior of the function. So I'm going to go ahead and divide every term by x to the second. So I'm going to go 3x to the second over x squared minus 5x over x squared plus 8 over x squared. So every single term gets divided by the highest degree in the denominator. So 2x squared over x squared plus 7 over x squared. And then next I get to simplify. This reduces out. This also reduces out. This reduces to just be x to the first power, and everything else kind of stays the same. So one more time rewriting this, I'm going to write my limit as x approaches infinity. It's going to be, I had 3 left over. I have 5 minus x plus 8x squared. In the denominator, I had 2 left over, and I had plus 7 over x squared. Now, the golden rule says that if I have any power of x left in the denominator, it's going to go to 0. And here's the golden rule again. Any power of x, denominator, equal to 0. So what that means is this 5 over x, that's going to go to 0. This 8 over x squared, that's also going to go to 0. This 7 over x squared goes to 0. So all that I have left over is 3 over 2, and that's my answer. That's my limit, 3 over 2. last example, number 9, is this rational expression. Again, I want to look at the highest degree in the denominator, the highest power, and divide every term by this, in this case, x to the third. So it's going to be x squared over x to the third plus 3 over x to the third, which is 10, x to the third. Then I want to go ahead and reduce and simplify. Alright, this reduces to just be 1. This just becomes x to the first power. Everything else, oops, I forgot this x on top of the 3. This reduces, it becomes x to the second power. Same thing, I can reduce these as well. I can reduce this one. This becomes x to the 2. And this stays the same. Simplifying this a bit. Now my limit, x goes to infinity. I had, this became 1 over x to the first power. This became 3 over x to the second. This stayed as 10 over x to the third. This became 4. This is 6 over x squared. And this over here is minus 7 over x to the third. Applying the golden rule now, any power of x left in the denominator goes to 0. So this goes to 0, this goes to 0, this goes to 0, this goes to 0, this also goes to 0. So what I have left over is 0 over 4, which is going to be just equal to 0. So this limit is equal to 0. Alright. Now, as far as the definition of a horizontal asymptote, all you would have to find is the limit as x approaches either negative infinity and positive infinity, if you're looking for a horizontal asymptote, and you would do so by the examples that we just kind of went through, and that's going to be dividing through by the biggest power in the denominator. Okay. There's 3 instances you could get. You could either get an actual number, like we did over here. You could either get 0, or you could also get infinity. And in class we'll be discussing what happens, what would be needed for you to get infinity as you take a limit going to infinity.